here next concept is metallic property and melting point of the D block element. This is a continuation chapters in the D block element in the second PC concept. Okay, after learning the atomic radii, when atomic radii increases from left to right and decreases from left to right and increases from top to bottom of the periodic table. In this periodic table, for example, this is periodic table. In this, go for the periodic table element from left to right, atomic radius will be decreases and top to bottom increases. Next, we go for the D block elements. Their metallic character as well as melting point of the. If once you know understanding metallic property, then melting point and they are very important, because I will tell you why this is. We see here one thing, a metallic character. If this is what in periodic table like this, the metallic character from left to right, metallic character will be decreases. The metallic character decreases. The metallic character will be decreases, and here will be what happens? Increases. From left to right, from this is what, for example, this is left and this is what right, and this is top and this is called as bottom. From top to bottom, metallic character increases, and here it will be decreases. Why it is like this? One thing, it is very simple. From left to right, the atoms, what happens? Then the tendency upon losing of electron will be decreases. Here what happens? For example, this is scandium to zinc. It does not. This zinc does not lose the electron. For next zinc, next one is copper. Here titanium. Like this. Here what happens? This one unpaired electron is there. One electron easily it will be lose, and it forms scandium plus. And next one titanium plus and vanadium. Like this, it will be lose outermost electron. But zinc, what happens? It does not lose the electron that much up easily. Therefore, whenever which element lose the electrons very easily, that shows the highest metallic character. Highest metallic character. Therefore, these scandium, from this left side, these elements are losing outermost valence electron easily. Therefore, the tendency to attain the metallic character will be increases. But this zinc, already the electrons will be completely filled. And next copper, it is only one electron acquired to complete the outermost electron. If one electron acquired means there will be valence electron will be completely filled. Therefore, this copper also does not lose the electrons that much of easily. Therefore, it's only a single reason. What is that? These electrons are loses the electron easily. They forms electropositive nature. The electron positive. Therefore, they are easily they are electropositive nature. Electropositive nature. Therefore, they are shows the metallic character. They are not at all losing the electron. Therefore, they are act as a. Therefore, they are not showing the metallic character. Next thing is it's very simple. From top to bottom. From top to bottom, what happens? These are for scandium. Next, go for this one. Scandium below group only. Scandium, yttrium. Next, lanthanum. These electrons loses a valence electron easily. Therefore, metallic character from top to bottom, what happens? Increases. Therefore, lanthanum plus, yttrium plus, scandium. These electron loses electron easily because they are lanthanums and actinides. They are the lanthanide elements, and F block element, they are losing electron easily. And one more thing, they are F block element, they are continuously radioactive elements sometimes. That's why they are losing the electrons and the masses. Therefore, they are high electron melting point. They are showing the high metallic character. In one exceptional case, the manganese from left to right, metallic character will be decreases. Yes, right. But one thing I will show in your textbook. What is that? This is what in textbook it is there here. What is that? I will tell you. Here melting point. They are given in the melting point in degree Celsius. Here what happens? That the tangential element, that is D block element. Here first metallic character, first what happens? Up to manganese. Here it will be increases. Manganese. Here for example scandium, titanium, vanadium. It will be increases. But manganese it will be decreases. manganese it will be decreases. Again next one iron, cobalt, nickel, copper it will be increases. This is what they are given. Next one, this is what all 3D series. They are all 3D element. Next to go for the 4D element. Again this one element for ytterbium, like this elements will increases. Next it will be decreases. Next it will be increases. This is what technetium. Next it will be melting point. This is what increases like this. This is what 4D series. Next 5D series. Therefore the metallic character increases with a completely half filled element. Completely half filled element. For example, this manganese. The manganese completely filled valence electron. For example, manganese electronic configuration Mn 3d2 4s5. Here 4s5 completely half filled. Therefore these electrons are completely half filled. Therefore it does not shows that much of metallic character. Therefore the metallic character of manganese technetium, these whatever manganese group element, they are showing less metallic character because they are completely half filled. Therefore a similar reason zinc, mercury and cadmium. Zinc, cadmium, mercury. It is zinc, after that cadmium, and after that mercury. Even though they are D block element, but they are not in metallic. For example, this mercury is in liquid. This mercury is liquid because it has outermost completely filled D block element, and therefore even though it is D block element, it is not metallic. It is liquid because it completely filled outermost electron. Therefore this is one of the exceptional D block element. It is not in metallic nature. That is clear now, because they are completely these elements are completely, because it is 3d10, it is 4d10, it is 5d10. Therefore our outermost valence electrons are completely filled. Therefore these elements are showing less metallic in nature. Next go for this is what similarly go for the melting point concept also. In this same melting point, in this here, this is what melting point. In this melting point also same, from left to right melting point will be decreases, and top to bottom melting point will be increases. Why this is? Because here metallic character decreases, atom melting point also decreases. Metallic character increases, the melting point also increases. Why this metallic character? Melting point ಮತ್ತು metallic character ಹೆಂಗ್ ರಿಲೇಷನ್ ಅಂತಂದ್ರೆ, melting point is directly proportional to metallic character. How this one? If metal, for example, melting point ಅಂದ್ರೆ ಏನು, ಕುದಿ ಒಂದು ಅಂತ ಹೇಳ್ತೀವಿ ನಾವು. ಈಗ ಅದು ಸಾಲಿಡ್ ಇತ್ತಂದ್ರೆ ಬೇಗ ಕುದಿತಿತ್ತು, ಲಿಕ್ವಿಡ್ ಇದ್ರೆ ಬೇಗ ಕುದಿತಿತ್ತು, ಗ್ಯಾಸ್ ಇದ್ರೆ ಬೇಗ ಕುದಿತಿತ್ತು. Of course melting point increases. First solids, next liquids, next gases. D block elements are almost all metallic mix, therefore they are showing the high melting point only. Therefore same property, this is also the melting point ekade ಹೆಚ್ಚಾಕೈತಿ akade metallic character ಹೆಚ್ಚಾಗ್ತದೆ, ekade decrease ಆಗ್ತದೆ, akade decrease ಆಗ್ತದೆ. In your textbook they are given this one graph also. First this is what increases like this. For example, this is what 3D series. Next they are given for one more 4D series. Next they are given one more for the 5D series. Here what happens? The melting point first increases like this, and next for mercury, for mercury, cadmium and zinc it will be decreases. Therefore they are less showing melting point. They are less because of this is they are not at all metallic character. They are not showing that much of metallic character. That's why the zinc like this, these elements melting point will be decreases. Okay, this is what very simple. Those nodri na idan bala shortcut I explain madini. I explain it this one very shortcut because you already learned this melting point, boiling point, character, atomic radius and everything in the first PUC chapter. Just whatever it is there in your syllabus. That's why I simply explain about this one for 5 minutes. That's it. Those who are learn classification of elements in past PUC element, they learn very well it is. Okay, of course it is not that much of important. Next I will go for one of the important concepts, then I will discuss very deeply. Okay, almost all this D block element chapter will be going to end. There will be only after that oxidation, oxides of D block elements, next halides, Next, after that, okay, one more ionization energy. How this ionization energy, and there will be one exceptions I will tell you. Then after that, we are going for the synthesis of two inorganic element, K2Cl2 and K-monopore. I will explain in the next videos. Thank you for watching my videos. Please share and subscribe my channel. Thank you.